Good morning, students. Today's class is one more sessions in statistics. Question number 8 to 10. So, question 8, 10 individuals are chosen at random from a normal population and their weights in kgs are found to be as follows. So, they have given the data of 10 individuals, the weight. So, the values are 68, 63, 66, 69, 63, 67, 70, 70, 71, and 71. So what is the question? Does the sample adequately represent a population in which the mean weight was found to be 66 kgs? Calculate the mean and justify. Okay, so here they have given the mean of the population. So we should now uh, calculate the mean of the sample and compare the both. So first for a comparison, we use a formula like we already discussed in introduction classes, that is standard error of the mean. So we have to calculate the standard error of the mean when we compare population mean with the sample mean. So first we need to calculate the mean, then standard error of the mean. So for standard error of the mean, I think if you remember the formula for standard error of the mean is standard deviation divided by square root of n. So now we are going to calculate the mean and also the standard deviation and also the standard error of the mean. Then we would be knowing whether this sample represents the population mean. So the solution is first we have to calculate the mean. Here are the brief steps how to calculate the mean, but I'm not going through in details because we already did this mean calculation in previous questions also. So the mean formula for mean is sum of all observations divided by number of observations. Here we have to construct a table like first column the serial number and also the x is the values they have given, those 10 values, and also the x bar is mean 678 by the total number of observations are 678 divided by 10, so the mean is 67.8 kgs. And also here x minus x bar, maybe if you want you can add one more column in between these two, that is x minus x bar. Okay, so that it will be easy to calculate x minus x bar square. Why we are calculating this? To know the standard deviation. Okay, so now we know the mean. Now we will be calculating standard deviation. From that we are calculating the standard error of mean. So but here we are not going through all the steps. Here they already calculated the standard error of mean, which is 0.903. Okay, so but in your record books, according to the formula, you calculate the standard deviation by using standard deviation. Calculate the standard error of mean by using the formula standard deviation divided by square root of n. When we calculate that, the standard error of mean comes to 0.903. So the conclusion is, does the sample adequately represent a population in which the mean weight was found to be 66 kgs? So first difference between population mean and sample mean is 60. Population mean, the one which they have given in the question is 66 kgs. Sample mean is 67.8 kgs. So the difference is 1.8. Is this difference acceptable? When it is acceptable only, we would say this sample represent a population. So how we know which is acceptable? For that, we need to do plus or minus 2 into standard error of the mean. So this 2 into standard error of the mean comes to 1.81. Okay, the 1.8, which the difference is between plus or minus 2, 1.81. So what does it say? The sample adequately represents the population. Okay. Question number 9. ESR, erythrocyte sedimentation rate in the first hour of 7 subjects aged less than 5 years are 5, 3, 4, 6, 4, 7, 9, and that of 7 adults aged more than 25 years are 10, 13, 16, 18, 21, 25, and 28. Find out among which group ESR shows greater variation. I think these type of questions we did in last class also. Question number 7, 6 and 7. 6, 7 we have given like a work for you to do. Those two questions, and this one is also same. So first, to know the variation, first we need to calculate the coefficient of variation. Okay. The formula for coefficient of variation is standard deviation divided by the mean. We have to do both groups. We have to calculate the coefficient of variation for the both the groups. So the first group, the mean is 5.43. Second, and also the standard deviation is 2.07. So by these values, we would calculate a CV, that the formula is standard deviation divided by mean. 5.43 divided by, 2.07 divided by 5.43, it is 0.38. This is for the first group, the children group. Okay. In the same way, we are calculating coefficient of variation for the second group also. So we have first, by the given values for each group, you have to calculate the mean for the second group, which is 18.75, and also the standard deviation is 6.42. The CV is 6.42 divided by 18.7, it is 0.343. So now we know coefficient of variation for the two groups. For the first group, below 5 years age. For the second group, more than 25 years of age. So for the first group is 0.353, 0.318 for the second group. So which one is more? 0.353. What does it say? The variation of ESR among subjects aged less than 5 years is more compared to the more than 25 years of age. Calculate the standard error of the mean from the following data. So here they have a given data, you should calculate the standard error of the mean. I think you remember the formula for the standard error of the mean, that is standard deviation divided by square root of n. So like all the questions, we would be calculating the mean, then standard deviation, then by using these two, we will be calculating the standard error of the mean. Please construct a table here with a serial number with all the values, and also the x minus x bar, and also x minus x bar square. Here the x bar, that is mean, is 2640 divided by number of observations, that is 10. So the mean is 264. Mean is here 264. So the sum of x minus x bar square is 2716. By this, we have calculated the standard deviation, that is square root of sum of squared differences divided by n minus 1, which comes to 17.37. So now we know the mean, which is 264. Now we know the standard deviation, 17.37. So standard error of the mean is, this is standard error of the mean is equal to s by square root of n. S here is standard deviation, n is number of observations. So standard deviation is 17.3. We have already calculated here, and also square root of n, that is square root of 10, is equal to 5.5. So the conclusion, the standard error of the mean is 5.5. Thank you.